Hello everyone, in this video we will cover two main sections. The first one is about sum formulas. So there's a sum formula for sine, cosine, and tangent. And then the next section is about double angle, which is extension of the sum formula. Okay, so this is essential in simplifying trigonometric expression and solving trigonometric equations later. So we already solved some trigonometric equations. That's why we're going back to, this is technically chapter 5. So this is, I believe, section 5.2 and 5.3 in the book. So the sum for sine says the following. So there's two formulas here. So we're going to work with this one first. So this is the sum, and this is the difference, okay? So the sum formula says that sine of a plus b is equals to sine of a cosine b plus cosine a sine b. I highly recommend you to memorize these formulas because you're going to use them many times in pre-calculus, calculus 1, and so forth. So one thing to know, though, this is very important. So note sine of a plus b is not equals to sine of a plus sine of b, and that goes pretty much for all the identities. So the formula is actually this. All right, so let's see when can you use this formula. So let's start and focus on formula 1. So notice that 75 is the exact same thing as 45 degrees. You can do this in degrees or in radians, plus 30 degrees. So 45 plus 30 is 75. So then this will be A, this will be B. So according to the formula, this is going to be sine of 45 cosine of 30 degrees plus cosine of 45 sine of 30 degrees. And then remember how we've been using special triangles for hundreds of times? Well, we're going to use those again. So let me do the special triangles one more time, because we're going to use it multiple times. So the 45 is this. The 30, this is 1, 2, right equal 3. So this is 60 degrees. So sine of 45, remember, is right equal 2 over 2, or 1 over right equal 2 over 2. Cosine of 30, if you memorize this already, remember, it makes life easier. Cosine of 30 is right equal 3 over 2. Then cosine of 45 is also right equal 2 over 2. And sine of 30 is 1/2. So then you multiply this, and this will be radical 6 over 4 plus radical 2 over 4, or just radical 6 plus radical 2 over 4. You can write this in different ways. You could have factored the radical 2 and then just write radical 3 plus 1 and so forth. Either way is fine. Also, 45, remember, is also pi over 4, and this is pi over 6. So you could also do this in radian. So as you can see, this is pretty straightforward. You either want to use special triangles, or you could have to create your own triangle and use the Pythagorean theorem to find the missing side, just like you have done in the previous sections, and then just apply it into the formula. All right, so now let's do 15. So for 15, we're going to use the different formula. Notice that 15 is the same thing as 45 minus 30. So minus 5 minus 30 is 15 degrees. Again, this is A and this is B. So we use the formula one more time. It's going to be now sine of 45 cosine of 30, but now it's going to be minus cosine of 45 and then sine of 30. You already have the values there, so this is essentially right equal 2 over 2 again, times right equal 3 over 2 again. So the values are the same. The only difference for this particular problem is going to be the minus sign. So the answer is going to be radical 2, radical 3 minus 1 over 4. That's it. So you can see this is pretty straightforward. Let me add an extra example here. Let's say that I ask you to find sine of a plus b, where, let's say, sine of a is equals to, let's say, 3/5, and cosine of b is equals to, let's say, 6/10. Okay. So notice here, these are two separate triangles they had to do. So this is a, so this is a, this will be 3, this will be 5. By the Pythagorean theorem, this is 4. You should check on them. And then b, cosine, this is 6, this is 10. You can check using the Pythagorean theorem, that is equals to a. So then if you apply the formula, remember this is sine a cosine b plus cosine a sine b. So then just plug it in. So sine a, we already know that is 3/5. Cosine b, we know is 6/10. And then cosine a is 4/5. And sine b is a/10. And then just simplify. So this will be 18/50 plus 32/50. So in this case, this will be actually 50/50, which is equals to 1. All right, so now let's move on to the same formulas, but for cosine. All right, so here's the first formula, the one for the sum. This is for the difference. Now, notice that the sum has a minus and the difference has a plus, okay? So let's try this. So cosine of 105, notice that this is the same thing as cosine of 45 plus 60 degrees, okay? So you use the formula, this is cosine of 45, cosine of 60, minus sine of 45, sine of 60. And then you can draw the special triangles again, or if you don't, especially you don't remember the values. Remember, cosine of 45 radical 2/2. Cosine of 60 is 1/2. This is radical 3/2, and sine of 60 is radical 3/2. Remember, if you want to make sure of that, just do the triangle. So this is 30, 60 degrees. Remember, this is 1, this is radical 3, this is 2. So then cosine of 60, this is 60 is 1/2. Sine of 60 is radical 3/2. So in the same way, you can do the difference. So therefore, cosine of 15 is the same thing as cosine of 60 now, minus 45. So then this will be cosine of 60, cosine of 45, now plus sine of 60, sine of 45, and then just plug in the values, which we already have. Remember, this is 1/2 times radical 2/2 plus radical 3/2 times radical 2/2, and then this simplifies to radical 2, 1 plus radical 3, the whole thing divided by 4. Now, there is also a tangent, sum, and difference formula, but it's usually easier to just use the identity that tangent is equals to sine over cosine. So for example, if you wanted to find like tangent of 15 degrees, this is the same thing as sine of 15 degrees, which we already found in the previous page, and then divided by cosine of 15 degrees. and then just plug it in. So for example, here the cosine, remember, was equals to this. That's what we just found in the previous problem, cosine of 15 degrees. And then sine was the same thing, right? 2, and then 1 minus radical 3 divided by 4, and this one will cancel. Actually, this is radical 3 minus 1. So this will cancel, so the answer will be radical 2, radical 3 minus 1, divided by radical 2 times 1 plus radical 3, and you still could cancel this, and that's it. Okay, so now let's move on to the next section. So remember, we use the sum formulas for sine and cosine. We also use the difference formulas, but now we're going to focus on the sum. So notice that this is the formula we just used, which was the very first formula, number 1. So notice that if A is equals to B, well, that implies that A plus B is equals to either 2A or 2B. So therefore, we're going to get a new formula, which we're going to call the double angle formula. So sine of 2A. So if you change B for A, this is what happens. So you end up with sine A, cosine A, plus cosine A, sine A, which essentially you get 2 of this. This is one of the formulas you're going to use the most in calculus 1, 2, and 3, and so forth. So I highly recommend you to memorize this one too. Okay? And in a similar way, you can find the formula for cosine 2A. So this is going to be cosine square A minus sine square A. And notice that you have this identity, sine square plus cosine square, which you can rewrite in 2 different ways. For example, sine square A is 1 minus cosine square A. So if you plug it in here, then you have cosine square A minus 1 minus cosine square A. So this will give you 2 cosine square A minus 1. So essentially, this one you can only write it one way, so only one way. But this one, it has technically 3 ways to write the formula, and depends on what you're doing. One is better than the other. Okay, so let's do this example. So let's say you have sine of 120. So notice that 120 is the same thing as 2 times 60. So that's the double angle. So according to the formula, this is going to be 2 sine of A. So this is A. Cosine of A. 2 sine A cosine A. But we already know that sine 60 is radical 3 over 2. And cosine 60, this should be 60 degrees. Cosine of 60 is 1/2. So this one cancel, and you end up with radical 3 over 2, which it should be not surprising, because remember from before, you have solved this problem many ways, or many times before in different ways. So for example, the way we did this at the beginning, the reference angle, which by the way you still need to know this, the reference angle, remember, is 60 degrees. So this is on the second quadrant, sine is positive, and since the reference angle is 60 degrees, well, sine of 120 has to be radical 3 over 2 anyway. So the fact that we got the same answer, that's good. If you didn't get this value here, then that means something was wrong. So essentially, you can do also this one this way, but we are supposed to do it now using these identities. So this one is going to be now cosine of 2 times 60. So remember, the formula says cosine square A minus sine square A. So that's one way. Or you can use the other 2 formulas. Either one should give you the same answer. So this should be cosine square of 60 minus sine square of 60. So remember that cosine of 60 is 1/2, so it should be 1/2 squared. And sine square of 60 is radical 3 over 2. square. So you square the whole thing, you end up with 1/4 minus 3 fourths, which gives you actually minus 1/2. And you can check here, like if cosine was on the second quadrant, remember cosine is negative, and cosine of 60 is minus 1/2, so it matches perfectly. Now finally, if you want to find tangent of 120, remember this is the same thing as sine of 120 divided by cosine of 120. And therefore this is radical 3/2 divided minus 1/2. This one cancels, so this is minus radical 3, which again is not surprising because this is on the second quadrant. The reference angle is still 60 degrees, but here tangent is going to be negative, and if you use a special triangle, you will get exactly this. All right, so now let's do a slightly different problem. So here you have a sine A, so let's do a triangle for that one. So notice that this is, if this is A, so sine of A is 3/5, so by the Pythagorean theorem, this has to be 4. We're not gonna use this one now for the first problem. So here, remember the formula for sine 2A is 2 sine A cosine A. So therefore it will be 2 times 3/5 times 4/5. So this will give you 24/25, and that's it. If you want to find, let's say that this one was B, sine of 2B, so then if we do the triangle for B, we do the same thing. Cosine, this is 5, this is 13, then this will be 12. This will be 2 sine B cosine B. So therefore, just plug in the values. So sine will be 12/13, and cosine B will be 5/13, and then just simplify. All right, so now what about cosine 2A? Cosine 2A, remember you had 3 formulas, but let's stick to the first one. This will be cosine square A minus sine square A. So therefore, cosine square of A, this will be 4/5 square, and sine square will be 3/5 square. So this will be 16/25 minus 9/25. So this is 7/25. And then finally, you want to find tangent. Remember, there's no need to use the formula, just use the definition of tangent. So this is sine of 2A divided by cosine of 2A. So this will be 24/25 divided by 7/25. The 25 is cancelled. This is 24/7, and that's it.